Still okay? Now let's continue. Now, the key point. I've been saying things in circles, okay? But key point is that the understanding of the distinction and relative independence between data structure and data type is a very important milestone in your computer language. Now, I believe that's why I want your video to be private. The main reasons many CS graduates have a problem is they never make the distinction. Okay. There is a user who are going to use your implementation, but they are using a data type. They don't want to care about the data structure you use. Okay. Now that is a modern invention because in a modern library, it is very important milestone in software engineering. Okay. Many modern languages have a standard APP library, in which you don't actually care. I can even tell you after the exam of this course, you never care about collision again, because they already have the best APP library. Now, so if with the best underlying implementation, application developer, whether you want to create an app that changes the world, whether you want to create a new web surface, whether you want to do finance calculation, you can now focus on solving real-world problems, rather than spending your hours trying to understand how data is solved. So in your course, you understand the underlying. So now you know. But in reality, say you're now going to do a program that will absolutely kill the stock market and make millions. You don't want to care about your hash function. That will be very bad. In some cases, maybe. You need to have very fast. In extreme case, yes. In the extreme case, yes. But ultimately, most of the time, you don't need to care. Because somebody has already done the best implementation and do the abstraction in the ADT, in the library, so you don't need to care. That is actually a very advanced, very important milestone, in which people suddenly can write all sorts of programs now, without worrying about the underlying. Right? When you worry about the very basics, you can't care about the top. As I said last time, maths is the very foundation, and then you move on. So you can move in a level in which you can solve real problems. But of course, we still have computer scientists trying to solve that problem so that we can solve other problems. So this is a very important thing. Now I hope after this course you still remember, even especially for those who are very good in programming. The underlying data structure is one thing. Ultimately, you expose to other people. It should be allow the user not to care about what's behind. That's actually a very important step in how computer science has stepped into the world. Normal people can also do programming without studying through many courses. Now, let's go on and talk about other abstract data type. Set. I can at most use a Venn diagram because most of you have learned probability that illustrate a set. Here we illustrate an intersection of two sets. Now, a set ADT stores a set of elements in an ordered manner, without any duplicates. So, say I simply want to have a set of the student names in this class. Now, a set have a following operations. You can add an element to the set, you can remove an element to the set, check it's empty, check the size, and I'm missing one here, see if an element is in the set. Now, in most of the cases, set can also be easily be implemented by a hash table. In a hash table, we have a key and value, right? You just make the value a dummy value. We call it a token value. So here, for an element x0 we want to add to the set, we can simply insert the key value pair x01. The 1 is not important here. It's just a token value. You can insert any random number, but people usually don't do that. Then 1 is a token value you can use for anything. Now, similarly, if you now want to add x1, we insert the key value x11 into the dictionary, into the hash table. So to check if the element x is in the set, we can look up x. And if it's not null, then we know that x is in the set. So basically, it's kind of like a cheating. But in reality, we have that a lot of times. Say maybe now, I want to do a pre-check. Again, online game. You want to create an online game account, then you create your account name. then usually you know that in any online service, it will tell you that your name is already taken, right? It's usually that what's happened, right? You have, I type in my name, John Chen, taken, okay? John Chen 2, taken. John Chen 3, taken, okay? So how do it actually goes through a set, right? It's impossible for them to go to the list. Imagine you are Hotmail, you are Gmail. There's literally millions of users. So this is also a hash table operation. But you don't get any value from that. Okay? You only get whether you are inside or you are not inside the set. Okay? And most of the time we use a hash function, hash table to do that. Now, so in this case, checking if a certain resource is already taken, IP, account name, okay? Checking if a number is a prime number. Saying I now want to check prime numbers. In security, we do a lot of things like that. I believe in previous courses, you have done any exercise trying to asking you to look for the prime numbers. It's impossible for us to do that, right? Likely we have a hash table for that, right? Why we want to calculate a prime number every time? Say here, you want a prime number of sufficient size 79199369 is a prime number. Okay? It's impossible for you to keep dividing number and then do a order of log n to order of n to try to find it. Okay, we create a pre-compute prime number table, and if it's in the inside, then it's a prime number, right? If it's not inside, then it's not a prime number, or in constant time. Okay, so it's very simple. And say remember a certain record has been updated recently. Okay, your recent files. Okay, is likely a hash table. Okay, without meaningful values. Okay. So any questions? It just means that when you have a set ADT or anything you want to model as a set, you can simply use a hash table, just like a dictionary, but with a token key. It seems to be rather obvious, but well, for beginners, usually you don't get it. Now, so if some complex operations that are set related are needed, such as union and intersection, then hash table may not necessarily be the fastest choice. But I tell you, in most applications, we don't really do union and intersection. Okay, they are math operations, but well, when you want to have a lot of data, of certain data, and you want to find intersection with another set of data, we usually call it database operation. Okay, and that is a completely different set of problems. We have a CS course called database management. Okay, that is actually the same. Say I'm Amazon or Taobao, and I want the customer who have bought this and another customer who bought this very popular item. I want to find the intersection. Now, in this case, that was some extreme case of data manipulation, and we actually call that database. And I believe most of you, what is happening?
Maybe you forget to connect the CUHK VPN. Maybe.
It's Google.
Google.
I believe I've been disconnected, right? Well, it says it's no internet again. Now I've been connected just now, right? Because I download things, but somehow. Okay, database. Now database is our ultimate data structure. It's in organized data in a relational database or some other things like that. So if you are a kind of person who are obsessed with data, then one day you need to study some database course. A database course is when your data is so large and so complicated that we need to invent some mathematical model to handle it. Okay? So after this course, you are qualified to take this course. Okay? It's not compulsory for IE here. When my times is compulsory. So database. Okay? Now, in other words, so in most of the time, you don't care about it, okay, in this course, because you don't know any data structure that can handle that. Now, another abstract data type is called ordered dictionary or ordered set. Now, so far we say that your dictionary have no order, right? So hash table have no order, so it's perfect fit. Now, but then in this reality, there's always order. okay, you want to have some order. Say the content list, name, room number. You want to find the highest rank and up to the lowest rank of people. Okay, then that is an order, right? Then in this case, we call it ordered dictionary or ordered set. You will need to return some first or last, or you want to get a range, okay, from the dictionary. Now in this case, suddenly, the hash table cannot handle that. Okay? The hash table cannot implement any ordered data structure. Okay? Now in this case, we want to combine the power of list and set and dictionary. Okay? And in this case, hash table is a data structure with no order. It will not be a good implementation. Array and linked list can be an implementation, but it can be too slow. Then what can we do? Right? Intuitively, up to now, you run out of tools. Right? If I use an array of 1 million in size, this is suicide as a web service, for instance. But if I use a hash table, I cannot give any order. Now, of course, some of you who are pragmatic will immediately come up with a solution. I use a hash table and a list. This is true in some cases, okay? Because as I said just now, okay, so when you have a space, you have lots of space, then of course you can keep a hash table, and then you keep a list, and then you always update them together. But in reality, we don't like that. Because if you fail in update one of them, then you get into trouble. Okay? So we need to have a data structure that can do all the things, okay, together. I will have an order. Okay? I can have fast lookup. Okay? I can find the first and last easy. So what can we do? It is actually trees. Now, trees. A tree is a very important data structure in computer science. Okay? But before we talk about implementation of tree by itself is also an abstract data type. Say I now want to have a family tree, then that data structure is a family tree, right? A tree is called a tree because you have a trunk and then you spread to other things. Okay? Now a tree abstract data type is a collection of nodes with parent-child relationship in a hierarchical manner without cycles. Now this is an actually formal definition. In a tree, you actually don't see a tree branch going back into the trunk, right? Unless you have some very strange tree. Trees always go away, okay? And they never go repeat, okay? Most of the time, okay? So this is a tree. Now, a tree always has something what we call a root. A root here is A. Okay? A is called a root. Just like in linked list with a head, a root of a tree represents the tree. Okay? We can go to any other nodes through the roots. Now, each of the roots and other nodes, we say, a root is also a node. Okay? Each of the nodes will have some children. They have one children or multiple children, okay? And each of the children can ultimately go on and have grandchildren, okay? Here, F, G, H, I are grandchildren of A, okay? And F is a child of B, okay? Now, at the very end, J, K are called leaf nodes, right? At the very top is the root, right? A tree grows from the root. And then it grows, ultimately it becomes leaves. So we call them leaf nodes, JK. So the wordings here, as I say here, a tree is considered nodes. And the nodes are connected by what we call edges. Okay, this line is called an edge. Okay. Now A is called the root node. If the root node is null, then the tree is an empty tree. Now A is the parent to B, C, D, E. A is the parent to B, C, D, E. And nodes with the same parent are called siblings. B, C, D, E are siblings. Well, we are interchanging between family tree and tree terminology, but this terminology is very important. It's common across all computer science. Okay? And Nodes can have 0 or any arbitrary number of children. Nodes with no children are called leaves or leaf nodes. Okay, leaf nodes. So JK are leaf nodes, FHI are leaf nodes. Okay. D is also a leaf node. Okay. So whenever there are no children, it's called leaf nodes. Now the depth is a measurement of how deep it is inside the tree. A root node has a deep depth of 0. The second level is 1. And ultimately, these two furthest leaf nodes, the depth is 3. Okay, we call it depth. Now, leaf nodes doesn't necessarily is in the deepest level. D is on the depth level of 1, but it's also a leaf node. Okay? A leaf node have no children. Now, we already have another measure, it's called height. Okay? Height starts with 0 from the last deepest nodes. It's just the reverse of the tree. So A is have a height of 3. Okay? So depth, you go down the tree. Okay? Height, you build from the bottom to the above. Okay? So in this case, we also measure the level you have in the tree. Now, why we bother about talking about the tree? Because tree somehow is a very magical data structure, okay, and abstract data type. Now, but before now, let's look at this is a tree, okay. We see that all of them have children, okay. Now, this is not a tree. We notice that there is a cycle here, okay. No trees have a cycle, okay, in real life. That is. This is a father, this is a son. The son birth people, the son does, this is the son, this is the son, this is the son. Doesn't make sense. Okay? It's impossible. It's not ethical unless you have some time travel. This grandson ultimately go back but this is not a real tree. Okay, so this is not a tree. Okay. Now, this thing is a linked list, you say. But the linked list is also a tree, right? A linked list is a tree with only one child. So you can imagine a linked list is a very Chinese thing. You have only one child policy. No, but you have two parents. Sorry. Sorry. Okay. But in anything, you have one successor and one successor and one successor. That is also a tree. Okay. A node is also a tree, right? It's empty. But this guy points to itself. It's not a tree. Okay. It's a cycle. Okay. Now, I have been very implicit, but a root cannot have any parent. So if a root has any parent, then it's not a tree, because it's a cycle. Okay? So this is not a tree. Now, again, this appears to have a no root. But then, one guy has more than one parent. No, again, not a tree. Okay? Not a tree. So, tree is very specific. Okay? These guys here, we have actually have a name. A dreadful name called a graph. Graph is the final data structure that we learn. And it's a nightmare as a data structure. Okay? And even I hesitate to talk about graph. Because when you have graph, there is no end. But most of you will do network. Ultimately, you will read some graphs. Okay? But then, let's hit it now to trees first. Okay? Trees is already messy enough, right? You have all the terms here. Now again, I repeat. The roots. The leaves, okay, and that is the depth, and inversely is a height, okay, and they are siblings, okay, the key terms. Now, they are useful as an abstract data type already, because in your computer, now the directory and the file name is a tree, is a key, right? But ultimately, you know that when I have a document. And, well, I have no documents here, let's have this. So here, you notice that when I expand all this, I have child folders, right? So this is a tree. You use a tree every time because your file system is a tree. Now, where and most internet resources are also a tree. Now, I don't think you have used internet for that long, or maybe you know that. And when internet was first invented, there is something called a sitemap.